be the calculus tutor for today. Our question is from Algae. This is in regards to surface integrals. The question asks, find the flux of the vector field F, I component Y, J component negative Z, K component X across the part of the plane Z is equal to 1 plus 3x plus 2y above the rectangle square bracket 0 to 2 for the x and for the y 0 to 4 with an upwards orientation. So for this first part, by definition, we need to find the flux. So flux is used for anywhere from, it's a quantitative flow rate per unit area. There's electric flux, there's momentum flux. There's a lot of applications of flux, and here we're just going to use arbitrary units in the Cartesian system. Getting straight into the problem, though, we know we have our three components. For general terms, for the general case, I just wrote P, Q, R respectively. And we have a specific surface defined by X and Y. And this is our Z. So we know that phi, or flux, is equal to the double integral over the region S of the dot product of your vector field and S. So expanding it, we will end up, this simplifies to the double integral of, you're going to have to evaluate the dot product of your vector field and then your partial derivative of your, so essentially Z with respect to X, Z with respect to Y, and K is remain the same. And we have our differential elements dx, dy, or dy, dx, depending which one's easier to integrate. So we have our function Z, our surface. We need to take the partial derivative. I mean, it's a constant. It doesn't get much easier than this. It's 3 and 2. So you replace 3 and 2 within here, but due to the orientation, these are negative. Our vector field function, y negative z x, gets dotted with negative 3, negative 2, 1 dy dx. You'll find out that there's a z, and essentially you were already given z as the surface, so substitute x and y z in terms of x and y, simplify it down, and you should be left with the double integral 0 to 2, 0 to 4 of y plus 7x plus 2 dy dx. I chose dy dx. And I reached a flux value of 88. And as once again, it can be in any units. It just has to be a flow rate over a specified unit area. The questions become a lot more difficult when there is parameterization that occurs in addition to non-rectangular, where the surface is not a perfect rectangle. And that'll be all for today. Have a good one.